శ్రీ ముత్తవరపు వెంకటేశ్వరరావు కాలేజ్ ఆఫ్ ఇంజనీరింగ్ అండ్ టెక్నాలజీ 2008 లో స్థాపించిన కళాశాలలో MBA, NAC A గ్రేడ్ మరియు ISO సర్టిఫికేషన్ సాధించిన మొట్టమొదటి కళాశాల శ్రీ ముత్తవరపు వెంకటేశ్వరరావు కాలేజ్ ఆఫ్ ఇంజనీరింగ్ అండ్ టెక్నాలజీ త్వరలో అటానమస్ కాబోతోంది. 2014లో ISO గుర్తింపు, 2015లో రాష్ట్ర ప్రభుత్వంచే A గ్రేడ్, 2016లో NAC A గ్రేడ్, ఇప్పుడు NBA సాధించిన సంస్థ శ్రీ ముత్తవరపు వెంకటేశ్వరరావు కాలేజ్ ఆఫ్ ఇంజనీరింగ్ అండ్ టెక్నాలజీ.
Good morning. In the last classes, we discussed about the trigonometric form of Fourier series and some problems related to trigonometric form of Fourier series. Okay, so we have done some problems related to trigonometric form of Fourier series. So what we have done there, so we have to find out the Fourier quotients, that is A0, An, Bn by using the formula A0 equal to 1 by T0 integral T0 to T0 plus T0 m of t dt, where m of t is an arbitrary signal, okay, arbitrary input signal, and an equal to 2 by T0 integral T0 to T0 plus T0 m of t into cos n omega naught t, and Bn is 2 by T0 into integral T0 to T0 plus T0 m of t into sin n omega naught t. Okay, after finding these values, we will write these expressions in the periodic signal, input signal, that is arbitrary input signal, that is m of t is equal to a0 plus sigma n equal to 1 to infinity an cos n omega naught t plus bn sin n omega naught t. After that, this form can be simplified by using the polar form. Why? Because it is a more compact form. Okay, so that is m of t equal to s0 plus sigma n equal to 1 to infinity sn cos n omega naught t minus phi or phi n. Okay, where Sn is mod Sn is square root of an square plus bn square, and phi n is minus tan inverse bn by an. After that, we will draw the amplitude spectrum and phase spectrum. Amplitude spectrum is the spectrum between amplitude versus frequency, and phase spectrum is the spectrum between phase angle versus frequency. Okay, in the same manner, we have the another form of the Fourier series, that is exponential form of Fourier series. Okay, exponential form of Fourier series. So here we have to know about the linear time invariant systems. Okay, linear LTA system, these are called LTA system. The physical processes can be modeled as LTA systems. While dealing with this LTA systems, it is very convenient to decompose any arbitrary input signal as linear combinations of basic signals. Okay, so we can define this LTA system as the linear combinations of signals. Okay, any arbitrary signal, suppose m of t is the arbitrary signal, m of t can be decomposed as the combination of the basic signals, provided these basic signals are having the following properties. What is the properties of these basic signals? So the set of basic signals can be used to construct a broad and useful class of signals. Okay, set of basic signals can be used to construct a broad and useful class of signals. Next, the response of an LTA system, linear time invariant system, to each signal should be simple and convenient to calculate. These are the properties of the basic signals. So first one is to construct a broad and useful class of signals, and these signals should be simple and convenient to calculate. LTA system, to the response of LTA system to each signal should be simple and convenient to calculate. Here the complex exponentials have both the above properties. So complex exponentials, here this is the exponential form of Fourier series. Exponentials means e power x. Okay, e power x. So the exponential or complex exponentials have both the above properties. What are these above properties? So it is used to construct a broad and useful class of signals, and the response of an LTA system to each signal should be simple and convenient to calculate. Okay, the complex exponentials have both the above properties, so they can be considered as basic set of signals. Okay, basic set of signals. See, in the above case, any arbitrary continuous time signal can be represented as combination of basic signals. Here, we are representing this arbitrary CT signal M of t as the combination of harmonically related. Related means harmonical signals means harmonics. Harmonics means first harmonic, second harmonic, third harmonic, fourth harmonic, up to we have nth harmonics. These harmonics may be either sine forms or cosine forms. Okay, so here the arbitrary continuous time signal can be represented as the combination of harmonically related sine and cosine components. Okay, see e power x sin x e power theta e power j theta. If we take e power j theta is equal to sin theta plus uh, cos theta plus j sin theta, like that. Okay, it is the combination of sine and cosine components. So these can be expressed in terms of exponents. Here m of t may be any arbitrary continuous time periodic signal, and whose exponential Fourier series is. So m of t is a basically an arbitrary continuous time signal, and whose exponential Fourier series is m of t. It is represented like this: m of t is equal to sigma n equal to minus infinity to infinity cn into e power jn omega naught plus, this is plus, Cn sigma n equal to minus infinity to infinity Cn into e power Jn omega naught t, where Cn is what is Cn here? Cn can be expressed as 1 by t naught integral t naught to t naught plus t naught m of t e power minus Jn omega naught t dt for n is not equal to 0. Here the exponential Fourier series form of m of t. Here basically m of t is an arbitrary continuous time periodic signal whose exponential form Fourier series is represented as m of t equal to sigma n equal to minus infinity to infinity Cn into e power Jn omega naught t, where this Cn is one expressed as 1 by t naught integral t naught to t naught plus capital T naught m of t into e power minus Jn omega naught t dt. Here n is not equal to 0, and c naught, if you substitute a 0 in the place of small n, then it will become c naught. C naught equal to 1 by t naught integral t naught to t naught plus t naught m of t into e power j into 0 into omega naught t, that is e power 0. E power 0 is 1. That's how it will become m of t into dt for n is not equal n equal to 0. Why? Because by replacing n equal to 0 in this expression, we will get c naught coefficient. So here the coefficients in exponential Fourier series form are C naught and Cn, whereas the Fourier coefficients in trigonometric form are A naught, An, and Bn. Okay, but here in exponential Fourier series, the coefficients are Cn and C naught. Cn is expressed as 1 by t naught integral t naught to t naught plus t naught m of t into e power minus Jn omega naught t dt. If you substitute 0 in the place of n, we will get c naught value. C naught equal to 1 by t naught integral t naught to t naught plus t naught m of t dt. Okay, so these are the Fourier coefficients in exponential Fourier series form. So like the trigonometric Fourier series, like the trigonometric form, here also we have exponential form. In exponential form also we have some problems related to Fourier exponential Fourier series. So here also there is a procedure for solving these problems, like trigonometric form. In trigonometric form, we have to find out the values of a naught, an, and bn, whereas in Fourier exponential Fourier series form, we have to find out the values of c naught and cn. Remaining everything is same. See the problem: find the exponential Fourier series and plot the magnitude and phase spectrum for the signal m of t as shown as. This is the given signal. It is varying from minus infinity to plus infinity, but here the limits are minus 2 to 2. What is the time period here given? Given the time period is from minus 1 to 1. that is minus 1 to 0, that is 1 second. 1 second. With this 1 second time period, it will be repeated. Here m of t is given as t, at everywhere its value is t only. From minus 2 to minus 1, its time period is 1 second. From minus 1 to 0, its time period is 1 second. 0 to 1, its time period is 1 second. 1 to 2, its time period is 1 second. So with this time period t naught equal to 1 second, it will be repeated. Okay, so it is a periodic signal, arbitrary periodic signal. Okay, so here the time period t naught is given as 1 second. So t naught is, as we know that t naught is the fundamental time period, f naught is the fundamental frequency. What is the formula for fundamental frequency? It is nothing but the reciprocal of the fundamental time period. So f naught equal to 1 by t naught, that is 1 by 1, that is 1 hertz. And after that we will find out the angular frequency omega naught. Angular frequency omega naught is nothing but 2 pi into f naught. What is f naught value? 1 hertz. 2 pi into 1, that is 2 pi radians. So first of all, here also in exponential Fourier series also, we have to find out this basic things here, basic parameters here. So at there also we will find out the basic parameters, and here also we will find out the basic parameters t naught, f naught, and omega naught. Then what is the signal m of t given? M of t is given as t for 0 is less than t is less than 1. Okay, 0 is less than t is less than 1. Okay, 0 to 1, its value is t. Okay, next what we have to find out, we have to find out the exponential Fourier series coefficients. Those are c naught and cn. How to calculate c naught value? C naught is equal to 1 by t naught integral t naught to t naught plus t naught m of t dt. What is m of t here? M of t is t. So 1 by t naught. What is t naught value? 1 second. It is 1 by 1 integral t naught to t naught plus t naught. Integral t naught, small t naught value is 0. T naught plus t naught is 0 plus 1, that is 1. M of t value is t dt. Integral t dt, that is t square by 2 with the limits 0 and 1, that is 1 by 2 minus 0 by 2. So its value is 1 by 2. So c naught value is 1 by 2. After that we have to find out the value of cn. Okay, so Cn, how to calculate Cn value? 1 by T naught integral T naught to T naught plus T naught m of t into e power minus jn omega naught t dt. Okay, it is 1 by 1. T naught value is 1. Here the limits are 0 to 1. Integral 0 to 1. M of t value is t. E power minus j n omega naught value is 2 pi t into dt. So it is in the form of, we have to remember the integral formulas here, integration formulas here. So it is in the form of integral t into e power at dt. Okay, integral t into e power at dt. So it is equal to e power at by a square into at minus 1. Here t is there, at is minus jn, a is minus jn 2 pi. Okay, so e power minus jn 2 pi into t by a square minus j 2 pi n whole square into at minus 1 minus j 2 pi n t minus 1 with the limits 0 and 1. Okay, so replace, substitute t equal to 1, and similarly t equal to 0 here. So this is the case. So it is equal to e power minus j 2 pi n into 1 by minus j 2 pi n whole square into j 2 pi n into 1 minus 1 minus 0, replace 0. So here, since e power minus j 2 pi n is 1 and j square equal to minus 1. Okay, so substitute the values of j square equal to minus 1. Okay, here j square, it will become j square into 4 pi square n square. Okay, and this will become e power 0. E power 0 is 1 by j square into 2 pi whole square, or 4 pi square n square. Okay, j 2 pi, this is 0 minus 1, it will become minus into minus plus 1, plus 1 by j square, that is minus 1. J square is minus 1, so uh, 2 pi n whole square, 1 by 2 pi n whole square minus half, and it will become, okay. So by simply substituting these values 1 and 0 here, we will get Cn equal to minus j by 2 pi n. Okay, minus j by 2 pi n, minus j by 2 pi n, or it is equal to Cn is minus j by 2 pi n for n is not equal to 0, or magnitude of Cn is j square, square root of j square by 2 pi n, that is j square is 1, so 1 by 2 pi n, mod Cn equal to 1 by 2 pi n. Okay, so C naught value is 1 by 2, and mod Cn is 1 by 2 pi n. After that, what we have to do, we have to draw the magnitude spectrum and phase spectrum for the given problem, like a trigonometric Fourier series form. Okay, here also we have to draw the amplitude spectrum and phase spectrum. Okay, right. So here theta n equal to, here Cn is 1 by 2 pi n. Theta n equal to, what is theta n? How to find out theta n? N. Theta n equal to, it is the phase angle. Okay, phase angle. Phase angle is minus pi by 2 for n is greater than 0, and is pi by 2 for n is less than 0. Okay, theta n equal to minus pi by 2 and pi by 2. Okay, see here. So theta n equal to minus pi by 2, that is a minus 90, and plus 90, minus 90 plus 90. Okay, theta n versus omega. So next we have to draw the magnitude spectrum as well as phase spectrum. How to draw the magnitude spectrum? Cn versus omega. So n values are like this. Okay, Cn is what is the Cn value? 1 by 2 pi n. 1 by 2 pi n. Okay, by substituting the n values at here, so that we will get if n is minus 4, 1 by 2 pi into minus 4, that is mod Cn. Mod Cn is 1 by 8 pi. So minus 3, minus 2, minus 1, like this we will substitute these values in mod Cn component, so that we will get the values like this. So at 0 its value is infinity. At 0, or at 0, at 0, 1 by 0, that is infinity. Okay, but here n is not equal to 0. Okay, right. At 1, at 2, at 3, at 4, similarly at minus 1, minus 2, like this we will get the magnitude spectrum or amplitude spectrum. Next, coming to the phase spectrum, so it is equal to minus pi by 2 for n is greater than 0. N is greater than 0 means 1, 2, 3, 4. Okay, so it is minus pi by 2. And for n is less than 0, that is minus 1, minus 2, minus 3, minus 4, it is plus pi by 2. So this is the phase spectrum. For m of t equal to t, the phase spectrum is like this, and magnitude spectrum is like this. Okay, is it clear? So it is also same as that of the Fourier series coefficients, finding the coefficients, but it is very easy. It is very easier than exponential Fourier series form is easier than the trigonometric form, right? Here we have to calculate only two coefficients, that is C naught and Cn, whereas in the earlier case we have to calculate A naught, Bn, An. After that we will write these coefficients in periodic signal m of t. After that, it will be converted into polar form. Okay. After that, we will find out mod Sn. Mod Sn equals square root of an square plus bn, and phi n equal to minus tan inverse bn by jn. Here we have to find out the Cn and theta n. Okay, Cn and theta n. Cn is nothing but C. This is Cn value. See mod Cn. Mod Cn will find out, and theta n. Theta n is nothing but 90 degrees, minus 90 plus 90 for this problem. Okay. So simply we can draw the, or we can plot the spectrums for magnitude and phase. Okay. Is it clear? Right. We will go for the next problem. See, this is the next problem. See, find the exponential Fourier series and plot the magnitude and phase spectrum for the signal given below. This is the signal given. It is exponentially decaying function, exponentially decaying, exponentially decaying function. So here the t naught is given as 1 second. Here also t naught is 0 to 1, that is 1 second. With this 1 second fundamental time period, it will be repeated, okay, up to infinity. This is plus infinity and this is minus infinity, and its function m of t is given as e power minus t. Okay, so first of all, we have to write the basic fundamental time period, that is t naught equal to 1 second, and f naught is reciprocal of the time period, that is 1 by 1, that is 1 h. Okay, so omega naught is 2 pi into f naught, that is 2 pi into 1, that is 2 pi radians. Okay, right. Next, m of t is given as e power minus t from 0 to 1. So for 0 is less than t is less than 1. Next we have to calculate c naught and cn. Okay, right. C naught is 1 by T naught integral T naught to T naught plus T naught m of t dt. M of t is e power minus t. Here the limits are 0 to 1. T naught value is 1. 1 by 1 into integral 0 to 1 e power minus t dt. Okay, minus of e power minus t with the limits 0 and 1. So by simplifying this one, it will become 1 minus e power minus 1. By using the calculator, we can calculate this value, that is 0.632. So C naught can be calculated as 0.632. Next, we will find out the value of Cn. Okay, value of Cn. So that is 1 by T naught integral T naught to T naught plus T naught m of t into e power minus jn omega naught t dt. Okay, so it is 1 by 1 integral 0 to 1 e power minus t into e power minus jn 2 pi t dt. It is in the form of, so here bases are same, then we can add these two. E power it is in the form of e power x into e power y, so that it will become e power x plus y. Like this, we will add these components. So e power minus, we will take minus as common here. So e power minus of t plus e power t as, so here t is there, here also t is there. Take minus t as common, so that it will become 1 plus jn 2 pi. Okay, jn 2 pi into dt. So e power x, it is in the form of integral e power x dt. Okay, e power minus of 1 plus j 2 pi n into t by minus of 1 plus j 2 pi n into n with limits 0 1. So by substituting these values 1 and 0 in this expression, we will get 1 by Cn as 1 by 1 plus 2j pi n into 1 minus e power minus 1 into e power minus j 2 pi n. Here e power minus j 2 pi n, since e power minus j 2 pi n is equal to 1, so replace e power minus j 2 pi n by 1, it will become 1 minus e power minus 1. Already 1 minus e power minus 1 value is 0.632. So it is 0.632 by 1 plus j 2 pi n for n is not equal to 0. Okay, so mod Cn is 0.632 by square root of 1 plus, this is an square plus jbn square. Okay, or x plus jy, c x square plus y square, square root of x square plus y square. So so 1 plus 4 pi square n square, and theta n is minus tan inverse bn by this imaginary term by real term. So 2 pi n by 1. So it will become minus tan inverse 2 pi n. Okay, this is magnitude and this is phase angle. So mod Cn equal to 0.632 by square root of 1 plus 4 pi square n square for n is not equal to 0, and theta n equal to minus tan inverse imaginary term by real term. So that is minus tan inverse 2 pi n by 1, that is minus tan inverse 2 pi n. Okay, what is the next step here? We have to draw the amplitude spectrum and phase spectrum. Okay, so in the next step we will draw the amplitude spectrum and phase spectrum. Okay, amplitude spectrum and phase spectrum. So here by taking n values from the negative side some values, from the positive side some values. So substitute these n values in this expression, 0.632 by square root of 1 plus 4 pi square n square. We will get mod Cn value like this. So these are the amplitudes. So mark these amplitudes at here. So we'll draw the waveform like this. So this is the magnitude spectrum, and similarly phase spectrum will be in between theta n and omega, that is in between minus pi by 2 and pi by 2, plus pi by 2 and minus pi by 2. If it is 1, if it is 1, n is 1, if n is 1, then it will become minus tan inverse 2 pi. minus tan inverse. If n is 2, minus tan inverse 4 pi. If n is 3, minus tan inverse 6 pi, like that. So that we will get the values at here. So this phase spectrum will be like this. Okay. So this is the magnitude and phase spectrum for this problem, that is m of t equal to e power minus t for 0 is less than t is less than 1. Okay. See, this is the problem. Okay, we have to find out C naught and Cn. After that, we will draw the amplitude and phase spectrums. Okay, so this is the amplitude and phase spectrum for the given problem, m of t equal to e power minus t. Next, in the same manner, we will find out the magnitude and phase spectrum for the given problem. See, it is the combination of two signals, and also here the problem is like an even signal m of t is equal to m of minus t. The original signal is equal to its mirror signal. Okay, so find the exponential Fourier series and plot the magnitude and phase spectrum for the signal given below. So this is the signal given. So here m of t, here we have two m of t functions. We have two m of t functions. First m of t function is m of t equal to 1 plus t for t is in between minus 1 and 0. Minus 1 is less than t is less than 0. Its value is 1 plus t, and from 0 to 1 its value is 1 minus t. So it is equal to 1 minus t for 0 is less than t is less than 1. So from minus 1 to 0 this waveform exists. With this time period it will be repeated. Okay, with this time period from 5 to minus 3 it is 2 seconds, but from minus 3 to minus 1 it is also 2 seconds. From minus 1 to plus 1 it is also 2 seconds. From 1 to 3 also it is 2 seconds. From 2 to 3 to 5 also it is 3 seconds. Okay. So T naught is 2 seconds. F naught is reciprocal of this T naught, that is 1 by 2. It is equal to zero point 0.5 hertz. And omega naught is angular frequency, that is 2 pi into F naught. So 2 pi into zero point 0.5, that is pi radians. And M of T is given as M of T equal to 1 plus T for minus 1 is less than T is less than 0, and it is equal to 1 minus T for 0 is less than T is less than 1. Now it is down. It is it is uh, it is time to find out the calculation of the Fourier exponential Fourier series coefficient C naught and Cn. So T naught C naught equal to 1 by T naught integral T naught to T naught plus T naught m of t dt. Okay. So here we have two m of t functions. So that's why we'll write 1 by t naught, that is 1 by 2 into minus 1 to 0, its value is 1 plus t, and from 0 to 1, its value is 1 minus t. So minus 1 to 0, 1 plus t dt, plus 0 to 1, 1 minus t dt. Expand this. Minus 1 to 0, 1 dt, plus minus 1 to 0 t dt. Similarly, 0 to 1, 1 dt, minus integral 0 to 1 t dt. Okay. So integral 1 dt, that is t. Integral t dt, t square by 2. Integral 1 dt, t. Integral t dt, t square by 2. So here are the limits are minus 1 and 0. Here the limits are 0, 1. Okay. By simply substituting these values in these expressions, so that we will get C naught value is 1 by 4 plus 1 by 4, that is 1 by 2. C naught value is 1 by 2. Next, what we have to calculate? Cn value. So Cn equal to 1 by T naught integral T naught to T naught plus T naught m of t in t power minus jn omega naught t dt for n is not equal to 0. Okay. So 1 by T naught is 1 by 2 with minus 1 to 0, 1 plus t into e power minus jn omega naught value is pi here. Is it not? Will substitute pi at last. Jn omega naught t dt plus integral 0 to 1 1 minus t t power minus jn omega naught t dt. Okay, expand this. So it is like this. Okay, so it is in the form of e power x dt, t into e power ax dt, t into e power ax dt. Already we have the formulas of integral t into e power ax, that is e power ax by a square into ax minus 1, e power ax by a square into ax minus 1. So by simply substituting these values in the above expression, we will get Cn equal to 1 by 2 into 2 by pi square n square minus 2 by pi square n square into minus 1 whole power n. So if n is 0, then minus 1 whole power 0, that is minus 1 whole power 0 is 0. So it will become 2 in 2 by 2, 2 by pi square minus 2 by pi square n square for odd values of n, and is 0 for even values of n. Okay, minus 1 whole power n, anything to the power 0 is 1. So this minus this 0. 0 into 1 by 2, that is 0 for even values of n. And it is 1. If it is 1, then minus 1 whole power 1 is minus 1. So this and this will be added. So 4 by pi square n square. This will become 2 by pi square n square for odd values of n. Okay, and theta n equal to minus tan inverse even imaginary term by real term. Okay, imaginary term by real term. So minus tan inverse here. Is there any real imaginary term here? There is no imaginary term. So that's why it is imaginary term is 0. 0 by this is real term 2 by pi square n square. So this is tan inverse 0, that is 0. Theta n is 0. So if theta n is 0 means there is no phase spectrum, only we have magnitude spectrum. So Cn equal to 2 by pi square n square for odd values of n, only odd values of n. We have to take the odd values of n only. Okay, so by taking odd values here, we will get the spectrum like this. So this is omega naught, 3 omega naught, 5 omega naught. Similarly, minus omega naught, minus 3 omega naught, minus 5 omega naught, like that, like that. Okay, so this is the magnitude spectrum. So here for even values of n, its magnitude mod Cn is 0. For odd values of n, its spectrum is like this. Okay, this is the magnitude spectrum. For this problem, we don't have any phase spectrum. Why? Because phase angle is 0. Imaginary term is 0. That's why we will consider only real term. So imaginary term by real term, that is 0. Tan inverse 0 is 0 only. Okay, right? Okay. So this is about the Fourier series. So here LTA system can be LTA system is a process in a physical process can be modeled as LTA systems. While dealing with the LTA system, it is convenient to decompose the arbitrary signal to linear combination of signals. Okay, so here the arbitrary signal is divided into, or we can write this as linear combinations of sine and cosine terms. Okay, sine and cosine terms, cosine components. So that is arbitrary signal m of t can be represented as integral n equal minus infinity infinity cn into e power plus jn omega naught t, where cn is expressed like this: 1 by t naught integral t naught to t naught plus t naught m of t into e power minus jn omega naught t dt, and c naught also. Okay, so by simply calculating the Fourier quotients C naught and Cn here, we will take the magnitude spectrum, magnitude function Cn mod Cn, and theta n is the phase function. So finally, we'll draw the magnitude and phase spectrums. Okay, and these are the different problems we solved. Okay, so this and so these are the problems related to the exponential Fourier series. Okay, with this. I will conclude this session, and in the next class we will continue the next topics. Okay, thank you.